Welcome back to the Cloud Native Platforms track here at Spring One. Our next session is one of my favorite types of talks, a real-world story about how Penske truck rental leveraged VMware Tanzu Observability to get full visibility into their entire stack. Over 2,500 containers with over 300 different streaming applications. Krishna Gogineni and Shruti Modi are here to tell the tale. Take it away, Shruti.
Hi, my name is Shruti Modi. I'm Director of Data Platform here at Penske. I have Krishna here with me, and together we're going to talk about observability implementation on our IoT platform at Penske. Krishna?
Hello, everyone. This is Krishna Gogineni. I'm an advisory platform architect at VMware. Super excited to be in front of you all and share our observability platform success and the details behind it. Shruti?
Yeah, so Connected Fleet project is about having a real-time interface with our truck constantly in real time and resolving their problem in real time, and also in some cases resolve the problem before even problem happens. Krishna?
Thank you, Shruti. Today, the agenda that we're going to be covering about is that for the observability platform, what observability outcomes that we set out to achieve by implementing the platform, number one, and give you a high-level snapshot of what the solution architecture looks like for the entire Connected Fleet project. And then we will get into the implementation details of like how is it being done for the application side versus the platform side, followed by what are the challenges that we faced and how we address them. Then we want to give you some highlights in terms of like what those dashboards looks like for the application as well as the platform. Shruti?
Thanks, Krishna. So when we started this project, we had specific goals in mind for our observability implementation on our IoT platform. We wanted to make sure that when incident happened, mean time to detect problems and to resolve problem is minimal. We also wanted device and truck monitoring without writing a huge set of custom codes or implementation on interfaces. We wanted metrics-driven dashboard and matrices for a platform and application for scaling decisions. We wanted tools to triage application and platform in case of any failure occurs. We also wanted consolidated one solution for our business, our application, and our platform. And lastly, we wanted to make sure we ensure on compliance and our law for government regulations. Krishna?
Thank you, Shruti. So before we embarked on this journey, right, from an architecture standpoint, from an application standpoint, there are some tenets that we wanted to take into considerations. Penske Connected Fleet is a huge Spring Boot implementation shop, right? So we wanted to get some out-of-the-box integration solutions for Spring Boot applications, number one. And there's a lot of microservices implemented in Connected Fleet programs. So we wanted to get all the microservices pattern support out of the box, another one. And as you can think about when you're talking about thousands of trucks and getting that real-time telemetry data into the platform, the way you would scale the data ingestion, similarly, accordingly, we wanted to get the scale of the metrics ingestion into the platform also to be working out of the box. And then we do not want to get stuck into a vendor implementation, and instead we want to focus on industry-based standards and have an implementation that is vendor neutral. And last but not the least, if you think about it, the metrics and the data ingestion, we wanted to retain the metrics that we collected for a longer duration time, so that if at all we have to go back in time and be able to compare and contrast and derive patterns, we want to be able to do it. Now, coming to the platform side, the platform team has been really, really vocal and upfront from the beginning that when we are implementing this observability platform, developers need to have a self-service capability. They do not want to be in the way of developers getting the tools that they need. Number two, since the Connected Fleet program is running in the AWS cloud environment, The team wanted to maximize memory and compute utilization by looking at the metrics data and be able to make the data-driven decisions. And anytime there are issues on the application side, if they are because of a failure on the platform component or the underlying infrastructure, they want to be able to tie from top to the bottom, number one. And platform team also wanted to have a vendor-neutral implementation. But the most important thing for the platform team is that Penske has a very strict security audit demands, be it within their public cloud environment or in the data center. So they wanted to comply with the security and audit needs like within the Connected Fleet program. Shruti?
Yes, so I'll give you a brief overview of our connected fleet architecture. So our trucks in real time talk to us and we ingest that data on an AWS platform, which we have implemented. The volume of the pings are about like 70 million, which is growing 75 million pings a day. And we have implemented in conjunction with Kafka, Spring Cloud Data Flow, and a Spring application hosted in a Tanzu application using this three backbone infrastructure. We ingest this data in real time, and then we make it validated and ready for different data stores. The data stores we use are like in-memory data store, which is for Gemfire, which is used for very fast ingestion of data and very fast retrieval of data for our truck locations. We also use Postgres for some of the specific geospatial use cases. And also for analytical environment, we have data lake into S3 and Greenplum for our analytical use cases. Now, we also have a front end created for some of these specific domain-based business use cases. We have MySQL tile implemented and microservices based front-end system for serving some of those specific business use cases. So to put the observability on top on this infrastructure end-to-end, we utilize Wavefront. Wavefront was advantageous because it had micrometer based functionality for some of these applications, which was hosted in a Spring Cloud application. And Krishna will talk in detail in next slide how the application was configured using this micrometer. Same with the Kafka and also for microservices based system. This was advantageous. This functionality was advantageous, and it gave us one single view of observability on Wavefront on a cloud-based solution. Krishna, do you have anything to add?
Yes, one other thing, if you look at the scale of the footprint, as you can see at the top, close to like 1,200 application instances, 85 stream definitions, like depending upon multiple use cases for how we want to process the data. And we are ingesting close to 700 gigs of data into the platform and in the environment, right? That's the scale that we are looking at. Now, if you want to look at a sample use case and a stream definition, right? For example, one of the Spring Boot application that is actually going and pulling the data from trucks, basically it is getting the data and publishing that data based on the provider for which it is pulling the data and publish it to a provider topic, right? The Spring Boot application has built-in Spring Boot actuator interface is leveraged for exposing all the metrics related to that Spring Boot application. Standard out-of-the-box metrics that Spring Boot provides along with the custom metrics that we actually expose. Both of them are collected by the Wavefront Spring Boot starter that is included into the application. So all the metrics are automatically captured and ingested into the Wavefront cloud. So once that provider specific data as is available in the topic, there is an event mapper that goes and consume the data from the provider specific topic. And because when the truck is moving on the road, there are multiple events, right? For example, geolocation is an event, engines fault diagnostics versus all these different event data that it collects. It actually understand all the event data. And then from a provider agnostic topic where all that event data is published, from that point onwards, there is another Spring Boot application that is part of that stream definition goes and consumes the data. It applies all the business rules that we need to apply to process the data and normalize it and publish that to a denormalized data topic from there, depending upon the target destination for that data in the data store. be it like Gemfire or Postgres or like MySQL database, or pretty much all data goes to Greenplum. As you can see here, end-to-end, all these Spring Boot applications that are part of a Spring stream, Spring data flow stream definition, the metrics are automatically captured. We have close to like 350 metrics exposed by each of these Spring Boot applications that are automatically ingested into the platform. Once you have those metrics in Wavefront, then you could derive as many insights as you can do it, right? Now, was this implementation simple? Did we not have any challenges? Obviously, the answer is no. One of the first hurdle that we faced is that developers were so busy in providing more features to the business counterparts. One of the key things that they wanted to do is that they do not want to write custom code to actually ingest that metrics into Wavefront Cloud. Thanks to Wavefront out-of-the-box Spring Boot implementation, where the Spring Boot starter is added into the form file, automatically all the metrics are collected and retained for 18 months, right? That's number one. And when you look at the Spring Cloud Data Flow Server, there are so many Spring Cloud streams that are registered with the Spring Cloud Data Flow Server. If you want to understand how many streams are there in the environment and what those streams performance and all of that, then again, there itself, Wavefront has an out-of-box Spring Cloud Data Flow integration where all the metrics are captured and made available so that the teams can derive real-time meaningful insights onto the footprint, what's going on. And last but not the least, with the microservices implementation, the call invocation happening across multiple microservices, along with the backing services, be it Kafka topics or like multiple databases and all of that. We wanted to have an end-to-end traceability whenever we want to trace a call from source to destination. And this is where another great opportunity for us, where we use the Spring Cloud Sleuth dropped into the application form file as a dependency, and automatically all the traces and spans were collected by Wavefront and ingested into the Wavefront Cloud, so that teams at any point of time want to debug anything, they had the ability to slice and dice the data at the customer level, truck level, or the device level. Shruti?
Yeah, so we had similar some challenges in platform as well, and I'll give you the highlights. We talked about volume of data which we are ingesting, and based on the large volume, there were times we were missing logs, and there was no way for us to know that and also to act on it. Having a built-in log aggregator as a part of Wavefront really gave that visibility. Not only it gave us the visibility, but we were able to actually adjust the instance count so that we don't miss the logs. Secondly, we had situations where our programs was going in a infinite loop because any reasons, like for example, we had a dead message in Kafka broker, and that loop was causing apps to crash, and in turn was causing our infrastructure Diago cells to crash. There was no easy way to pinpoint app to the the Diago cell to the infrastructure, and having that out of the box visibility in Wavefront gave us that ability to do that, and we were able to resolve the problem a lot faster than in the past we were able to without that having that observability. Lastly, the main value which we think is really amazing for us is to have the predictability of platform scaling based on an actual real data which we are finding at out of the box Wavefront, and that is because of the real integration with DAS and able to monitor the platform components at the and scale it at each component level. Krishna?
Thank you, Shruti. So let's look at how does that observability even look like for, let's say that whenever a business counterpart wants to come and ask you to slice and dice the data and give him a viewpoint into what's happening in production. So for example, as you have seen, the Polar applications are going and polling the data, right? And when they are doing it, they're polling it for multiple providers, customers, devices. There are multiple levels of granularity at which you want to derive these insights, right? because of the metrics exposed through the Spring Boot actuator ingested into the Wavefront cloud, what we could do it is that we were able to create dashboards like this, where if you want to get insights into the polling cycles, how many polling requests are happening at any given point of time, and how many of them are actually successful versus how many of them are not successful. If there are any skipped polls are there, that level of granularity data is available out of the box for us. That's number one. Then if you want to look at poll cycle insights in terms of like what is the average poll cycle, what is the response time, and all of that, on top of that, if you want to leverage the data to go across, like saying that how many polls are like spread over multiple customers versus devices, all those fine level of granularity of data is available in a single place. Anytime a business counterpart and comes and asks, we would quickly go through these dashboards and make those details available to them, which worked wonders for us, right? That's number one from a business standpoint. But then when you come to the application life of an application developer, you need a telemetry of like how your application instance is doing in production environment, right? For example, what is the uptime of your application instances? What is your heap usage? What is the CPU usage? Are there any block threads? And like, how many receipt requests versus how many are you processing? Is there backlog going, and all of those details? All the data is available through the Spring Boot actuator exposed metrics, and we made it available to ourselves. And we could slice and dice this data based upon, let's say that a specific business area, like in a specific use case versus overall across like production foundation. So that's the ability we were able to get. Next, Shruti.
Yeah, so from platform perspective, we had our own advantages. We were able to visualize this health metrics in a single pane of glass. Also, having this three separate group, app, platform, and DevOps environment, and a business environment, we were able to provide them their personas and be able to have them self-service environment where they can have their own look and feel of their front end dashboards. We were also able to utilize real-time platform capacity and utilization observation. And a historical view of data also gave us ability to predict how much utilization we anticipate in future, and was able to scale accordingly. And having this proactive alert setup, which we are still in the process of doing, helped us monitor failure and predict failure before even had happened, and resolve the problem as quickly as possible. Krishna?
Yep.
And from platform perspective, maintaining the platform and monitoring it for resource utilization was another aspect which we checkboxed in Wavefront. As you can see, we are able to see CPU utilization, memory utilization, not only at the task level, but we were able to drill through at the level of application and also at the isolation segments, Diago level and isolation segment level. And this was a huge win.
Yep, thank you. So one of the key things is that, as you can see here, without this eyes on glass capability from an end-to-end observability standpoint, it would be extremely difficult whenever there are problems. So that's why from the get-go, observability is one of the key tenets of the platform foundation, where, for example, all the metrics, logs, and traces and histograms, everything is collected out of the AWS Connected Fleet Program foundations. One of the key things is that Wavefront is able to capture all the platform, app, health, and performance monitoring with metrics ingestion and dashboards and alerts provided out of the box. Wavefront had always these, by default, a standard opinion about how the dashboard should look like. So there are a lot of dashboards available out of the box. We used most of them to start with. And after a point, we had custom requirements in terms of how we want to create additional dashboards. All of them have been created by us on an ongoing basis as and when new requirements are coming. And another important aspect is that the distributed tracing, where simple addition of Spring Cloud Sleuth with open tracing telemetry emitted by these microservices, we were able to get all these distributed traces into the Wavefront cloud. That had made a huge difference in terms of how we would react to problems in production environment or non-production environments versus how do we detect those problems. Shruti?
Great. So in summary, with Wavefront implementation, we were able to reduce our mean time to recovery by 75%. It also gave us full stack observability at the single pane of glass. We were able to monitor end-to-end fleet performance with metrics. Scalability and ongoing capacity planning was also very, very data based on data rather than guessing it without any metrics. Our developers and platform engineers were able to get to root cause analysis given the metrics and the triage we had set on those metrics. We also were able to consolidate our business application and platform metrics on a single place, which was I thought was amazing because platform didn't want to be in the business of configuring various tools on the platform, and we were able to do this with one single place. Lastly, anomaly detection and fixing issues have saved us a lot of time and cost for connected fleet program.
Thank you, Shruti.
Yes.
I would add a couple of other details on top of it is that at the end of the day, the quality of life of the application developers as well as the platform engineers have become really good, because at the end of the day, you're not getting those production tickets or service calls and all of that. That has been a huge win, in my opinion, in terms of team did a fantastic job. With that, Shruti, back to you.
Yeah, I want to thank and acknowledge my platform team, Platform Phoenix team for implementing this, and also our BDIS team, the data integration team, would spend a lot of time in configuring their application dashboards and using this tool to configure their triages and monitoring. I also want to bring this up, our career page at last, because we are hiring, and please go ahead and take a look at all our positions. As you can see, we have exciting environment and lot of cutting edge technology implementation of various projects using this cutting edge technology. Krishna?
Thanks, Shruti. I would second what Shruti has said. If you want to explore these opportunities, Penske is an awesome place where you could make use of all these awesome technologies and be able to solve difficult problems for the end customers. With that, thank you, everyone. And
thank you.
We would be happy to take any questions in the Q&A Zoom session. We would be transitioning on to that Zoom session and more than happy to answer any questions you may have.
Thank you.
Shruti and Krishna, thank you for sharing such a riveting story. Truly great work. If you have any questions for our presenters, please click the Slack link in the Now Playing tile on this web page. And from the Slack channel, you can find a Zoom link to this presentation's Q&A session. And it's break time. Grab a refill on that drink. Take a bio break. And I'll tell you what not to do. Don't shave a yak. There isn't enough time. But there is enough time to Google what the phrase shave a yak means, or don't shave a yak. I just learned that idiom yesterday during Layla Porter's test-driven development talk, and I've resolved to incorporate it into my vernacular henceforth. Anyway, see you back here at 3:35 Eastern for the next presentation.